Hello, and welcome to this edition of the 2024 Von Karman series. I'm Nikki Wyrick from JPL's Communication and Education Directorate, and I will be your host for this discussion, Sulfur Crystals on Mars, Curiosity's Happy Accidents, and Other Surprises. Scientists were stunned when a wheel on the Curiosity rover recently cracked open a rock to reveal something never seen before on Mars, yellow sulfur crystals. We'll discuss this and some of the other notable discoveries from the mountain climbing Mars explorer's 12th year on the red planet. Joining us as co-host is Sarah Marcotte, Mars Public Engagement Specialist at JPL. Hi, Sarah.
Hey, Nikki. Great to be here.
Thanks for being here with us.
So I will be taking your questions. So this is your space program. So whether you're watching on LinkedIn, YouTube, or X, we want to make sure that your questions get brought into the program. So ask them in the chat box, and members of our social media team will bring them into the discussion, as many as we can. And if you don't see a chat box, try refreshing your browser, and it should show right up.
Awesome. Thanks, Sarah. We'll come back to you in a bit for a bit of those viewer questions. As a reminder, if we do run into any technical difficulties, we ask for your patience and we'll sort them out as soon as we can. Our speaker for this discussion is Dr. Ashwin Vasavada. Ashwin is a planetary scientist at JPL and the project scientist for NASA Curiosity rover that began development in 2003 and successfully reached Mars in August of 2012. Joining us live from the center of the universe and the home of NASA's very active Deep Space Network, Dr. Ashwin Vasavada. Hi, Ashwin.
Hey, Nikki. How are you?
Great. Thank you so much for being here. What can you tell us about this happy accident?
Yeah, love to tell you about it. So if you put up slide number 1, this is a view we had a few months ago as we were climbing up Mount Sharp, as we've been doing for the past 10 years or so. And we looked out ahead and we were kind of scoping out places that we'd like the rover to go so we could study the various rocks and soils that we see in front of us. And we saw this huge patch of bright white rocks. Everything there on the kind of center and right part of the screen, it goes about 50 yards into the distance, so like half the size of a football field. It's just covered with these kind of fist-size, very bright white rocks. And so we decided to go check them out. We really hadn't seen anything like that before. So we drove over there, and if you go to the next one, you can see what one of these looks like close up. This is about 6 inches across, and as we got up closer, it still didn't really make a lot of sense to us because we hadn't seen anything like this. Very bright white, lots of holes in it, just kind of strange looking, even for Mars. And the happy accident is what happened next. When we got in a position to look at these rocks, we realized that on the way in, we actually were driving backwards. We drove over one of these and totally kind of crushed it with this 1-ton rover. And when we took a look at it, we took some pictures of it. We actually took our arm out and got some even closer pictures with our camera at the end of the arm. We saw this amazing sight. These rocks, inside of them, are these gorgeous green-yellow crystals. What really brought this all together and blew our minds, frankly, is the fact not only were there these beautiful crystals inside, but when we measured the composition, they were pure sulfur, just the element S, nothing else.
Why is finding pure sulfur so surprising?
Yeah, you know, on the one hand, it shouldn't be, arguably, because terrestrial planets like Earth and Mars have a lot of sulfur in their crust and in their insides. And in fact, we've been climbing through rocks on Mars that we've been calling the sulfate unit, meaning that it has a whole bunch of this sulfate material, sulfur combined with oxygen into a salt that's a part of these rocks. But that kind of is the point. A lot of times on Earth and Mars, sulfur will be combined with something else, whether it's hydrogen or oxygen. It'll be in the form of a sulfide or a sulfate. It's pretty rare to find just plain old S lying around, sulfur. That tends to form in very special environments on Earth, like near a volcano, near a hot spring, or near a cold spring. None of those things we expected to find in this location on Mount Sharp on Mars. So it's pretty surprising.
Man, what a surprise. When this news broke, Curiosity's social media really blew up with questions like, could this be a meteorite that hit Mars? And is this the sole instance of pure sulfur on Mars? What are your thoughts about how it got there?
Yeah, it's the first time that any mission on the surface of Mars has found pure elemental sulfur lying around. And we'd love to know how it got there. And Mars really hasn't given us too many clues at this point yet, so it's going to take some detective work. We don't really suspect that there's any volcano anywhere near Curiosity, but we do know, and we'll talk about this later in today's live stream, that we have some idea that we're in a place where water once flowed across the surface. So we're kind of focusing on the idea that maybe there was a warm spring or a cold spring that could have caused these rocks to form. But all we see really is this huge field of these white clumpy rocks. So not much to go on, unfortunately.
Yeah, I mean, it's great to know that there are some questions we just don't know the whole story to yet. Speaking of questions, Sarah, I'm sure the audience has already started asking questions for us, and we want to start bringing those questions in early. So what have we got so far for Ashwin?
Okay, so Rick Brick on YouTube is asking, so what does this sulfur discovery actually mean? Does it have anything to do with signs of past life?
Yeah, as we were just talking about, we're really hoping to figure out a little bit more what it means. We're looking for clues to figure out whether it formed maybe in a hydrothermal environment or a cold spring. On Earth, there are things, there are processes that can form this elemental sulfur that involve microbes. Now, we have no reason to suspect that on Mars, and there's a lot of other ways that this sulfur could form on Mars. So, there is a connection to life when you find this sort of thing on Earth. On Mars, I think we have to hold open other explanations as well.
Okay, so I do have another question. So this is from Sammy Connor on YouTube. So how much sulfur is suspected to be under the Martian surface? And what could it tell us about the history of Mars?
Yeah, so terrestrial planets have a lot of sulfur that is in their entire interior, in the core and in the mantle and the crust. And some of that sulfur comes out in volcanoes, and that's the sulfur that then forms, that combines with oxygen and hydrogen to form different minerals that are on the surface. So there's quite a bit. The rocks on Mars might have a few percent of sulfur in them. The sulfate unit has 10 or 15% of sulfate minerals in them. So it's a good amount.
Okay, Nikki, can we do one more?
Yeah,
because they're coming in hot and fast. So we have another question from YouTube. So Art Borja is asking, could some of these clumpy rocks have been at the bottom of a stream at some point?
Sure, yeah, that's one possibility. In fact, as we'll talk about later on, we're in the middle of what we think is an ancient riverbed. We don't know if that has anything to do at this point with the presence of sulfur here, but the fact that we found them while we're exploring an ancient riverbed means we should probably try to connect those dots and see if there's any significance to that.
Excellent. So we are going to come back to Sarah a little bit later for some more of your audience questions. So please keep them rolling in for Ashwin. But Ashwin, I want to jump back with you for just a couple more minutes. This is all very exciting, but we talked 10 years ago, and since then, or we talked 2 years ago for the 10th anniversary, and since then, Curiosity has made some other exciting finds, right?
You bet. We've been climbing Mount Sharp, steadily going layer by layer, and one layer we really wanted to get to is this dark band of rocks that you can even see from space. You can actually trace this very dark, ledgy rock layer across Mount Sharp for many tens of miles. So we're excited to go check it out. And we had no idea from the pictures from orbit whether, how this dark ledge got there and what it means. And so Curiosity rolled up to it and saw this view that you're looking at here. And it didn't immediately answer any of our questions. In fact, it was, again, pretty strange. These rocks that are in the foreground are ones that had broken off from that rock ledge and tumbled down, and they just look really strange. It almost looked like an ancient lava flow, but again, we don't think there's any volcanoes around here. So we started piecing together other clues, like looking at the rocks that are jutting out from the layer, and what's shown on the inset there is looking at this rock layer edge on. And you can see kind of in the top of that rock layer, there's some wavy parts to it. And that started giving us our first hints of what was going on. But it really got a lot clearer when we drove Curiosity to the top of the rock layer and then took some pictures. And that's what's shown on the next one. Here you can see what just jumps out at you is these beautiful ripples, like you'd see if you were walking across a sand dune or a beach. And we started measuring the shape of these ripples, and they're very symmetric. They're just a few inches apart from each other. And after comparing them with what you'd expect in ripples that form from wind or from water or from rivers or beaches or lakes, we determined that these ripples formed at the bottom of a shallow lake a few billion years ago when wind was blowing across the surface of that lake and causing waves, and the waves were jostling the water back and forth. And then a few feet down underneath the surface of that lake, the sediment, the sand, and the silt was also being jostled back and forth, and that's what created these ripples. And in the inset there on the left, there's a picture from Earth of a beach where the waves are going back and forth and creating very similar symmetric wave ripples on that surface.
Curiosity has found evidence of ancient lakes before, right? So how is this different?
Yeah, it's different in a couple ways. So we found evidence for a lot of lakes lower down. In fact, lakes that we think lasted for hundreds of thousands or millions of years. But then we drove higher on Mount Sharp into an area. So the layers on Mount Sharp, the older ones are at the bottom and the younger ones are as you go higher. So that as we drove higher and higher, we got younger and younger layers, and we really had strongly believed that we would cross into an era where the lakes disappeared, Mars' climate started changing, and on the upper layers of Mount Sharp as we were driving through them, we would be getting into places that formed in a dry climate, no more lakes. And so, in fact, we started seeing evidence of that. The layers that formed in lakes disappeared, and we started going through rock layers that formed when ancient deserts were there and sand dunes were there. So the fact that we then found this marker band, which with these wavy ripples in it and evidence of a lake, was another kind of interesting surprise for us. That Mars climate, even though it was going from wet to dry, it varied. It became wet again at some points. And I want to point out one other thing that was really cool about this find is this is the first time we saw evidence of these ripples so clearly. In all those lakes we'd seen before in the mission, we didn't see evidence of ripples that formed kind of near the shore in the shallow part of the lake where the winds were blowing. And this, not only was that just neat geologically, but it told us something really important, that the lakes were not covered by ice. So there's a big kind of debate in Mars geology about whether the earliest parts of Mars history were really cold, or whether they ever got warm enough to have a lake like this with no ice cover. But to form waves via wind, there can't be ice coating the surface of the lake. So this told us at this point in Mars history, the climate was warm enough to have a lake sitting there without any ice so the winds could blow and form the waves.
That's exciting. Since March, Curiosity has been exploring a region called the Gediz Vallis Channel. Can you tell us a little bit more about that and what it is?
Sure. I think the best way to do that would be to start kind of zooming out. So if you go to the next graphic, this is just a view, kind of an illustration of the side of Mount Sharp that we're climbing. And we've been climbing through the layers of Mount Sharp, and you can focus kind of on the left where you have the green layer, the clay unit, and the yellow layer, the sulfate unit. So that's, those are sort of the wetter layers and the drier layers that we were driving through. And then in the middle of the image there's a valley that we call Gediz Vallis. And if you start at the top, there's a channel where a river once flowed. And then you get that red part, which is a huge pile of debris that was brought down as that river was flowing down from the top of Mount Sharp. And then the blue part, the green hue pediment, is where once all that debris spread out into a big fan across the crater floor. So Curiosity has started from the bottom of the crater, driven through that clay unit, drove alongside the blue part and the red part, and in the last few months got all the way up to the Gediz Vallis channel, which is this ancient riverbed.
And I think we want to head on to this next image. What are we looking at here?
Yeah. So this is a close-up view of just the Gediz Vallis channel part, where that riverbed is seen there as that winding feature in the middle. And you can see how it's cutting across the layers of the mountain there.
Why is this location important, and what new information has it given us?
Yeah, it's important because it's one of the last geological events that's recorded on the mountain. You know, we talked about how the bottom layers are the oldest and the top layers are the youngest. Well, when you see something like this where a river is cutting across the young layers and the old layers, it means that it formed last. And we're pretty convinced after studying this river channel, and the debris within it, that water was involved in carving the channel and bringing all the debris that you see piled up in the middle of the channel. So that means that after all those old layers with the lakes, after the young layers with more, rare lakes, after all that, water flowed across the surface of Mount Sharp with a lot of force to carve this channel. So Mars' climate is a lot more complex than we imagined. And it means that water flowed pretty late in the early history of Mars. And if you go to the next graphic, you can see what it actually looks like from Curiosity's perspective. So here we are looking downhill. We're in the middle of the channel, so you can see all the debris, all the different color rocks that have washed down from higher on Mount Sharp. Those are on the right part of the screen. You can see the sulfate unit, which is what the channel was carved into, on the left part of the screen. And then off in the distance, you can see the Gediz Vallis Ridge, which is that red thing in the previous graphic where all that debris piled up down below this channel. And then I'll draw your attention to the foreground, where you can see where those white sulfur rocks were. So they were right in the middle of this channel. Most of the debris isn't those sulfur rocks, but this one little patch that we stumbled across, well, about 50 yards wide, is where we saw all those sulfur rocks.
So I see that we've gotten a ton of questions from our audience. So Sarah, I think it's time to bring in some more of those questions.
All right, thank you, Nikki. So the ripples are very interesting to people. So I have a few ripple questions. Let's see. So this is Dean Model on YouTube asking, actually, I'm going to kind of combine several of these ripple questions because I think because they look so much like something that we're familiar with. So we have Dean on YouTube is asking, how did those ripples stay preserved until now?
Yeah, it's a good question. So really the best way that they'll probably get preserved is just by kind of getting buried pretty quickly. So the ripples formed, and then for whatever reason, the water maybe calmed down, so more waves didn't destroy the old ripples. Sometimes we see the ripples getting covered by layers of mud, and that would help sort of preserve their shapes as more and more layers get deposited on top. And then, like all the layers we've been studying on Mount Sharp, eventually they become cemented together and dried out, and they form into actual rock.
Okay, so this is kind of related. So Maddie Gediz on X is asking, so do we have any idea when in Mars's history the water was likely warm enough to be able to create those ripples?
Yeah, so the earliest part of Mars history is when we have the most evidence for ancient water, not here at Gale Crater, but in other parts of Mars. There's rivers that have cut across the surface of Mars that we see the valleys left by those rivers behind. And that was, 3.5 to 4 billion years ago or so. Gale Crater itself, the crater that Curiosity is in, didn't form until about the end of that period, 3.5 billion years ago or so. And we think all of the mountain was deposited, and then this river was formed within a few 100 million years after that. So maybe 3.5 billion years ago to maybe 3 billion years ago at the latest. And so for the last 3 billion years of Mars history, really little has been going on in Gale. So that's the time period we think all this would have happened.
Okay, one more related question, because you're talking billions of years and 3.5 and 3 billion years ago. So John Bernal on YouTube is asking, does Curiosity have the ability to actually date the rocks it finds? So like specifically know exactly how old a rock is?
Yeah, we don't really have the capability to do that. So the main way that that's done on Mars and on the moon for that matter too, before we brought rocks back from the moon, is by counting the number of impact craters on various surfaces. So we have a pretty good idea of how many things were flying around the solar system in the early part of its history versus now, and how many things would have then hit the surface of the moon or Mars. And so you can find a surface and just count how many times it was hit by an impactor, a meteor or a comet. And basically, you know, the larger ones and the more they are, the older that surface is. So that's a lot of how we understand how old some of these landforms are in Gale Crater. Now for the moon, we brought rocks back and we can actually figure out their ages, and we hope to do that for Mars one day too.
Excellent. Good to hear that we are going to be doing that. Ashwin, it's been 12 years since Curiosity landed on Mars. How's the rover doing?
Yeah, rover's doing better than we ever could have hoped. And, you know, it really is an amazing mission. And the rover has accomplished as much as any spacecraft that has ever gone to Mars. And this is really because we've been there so long. We've had 12 great years exploring this fascinating landing site, and we've accomplished so much science. It's also because of the payload that we were able to bring with us, bringing laboratories to Mars and being able to drill samples and understand so much about this, the history of Mars. And that's also finally because of our team of incredible engineers and scientists who've just given so much of their energy and passion and lives, you know, to make this mission what it is. So, you know, we have this beautiful picture, it's one of my favorites, where we can look back and see how far the rover's come. You know, all the way off in the distance there is the crater rim. Just in front of that crater rim is the floor where Curiosity landed 12 years ago. I was in the room behind me cheering along with everybody. And then you can just see the trail that we followed now for 12 years getting to where we are today. The next graphic is our gallery of drill holes. So 42 times over the 12 years now, we've drilled into Mars, extracted rock powder, and analyzed that rock powder with our onboard laboratories. And every one of these rocks is a memory for me and for the team of the challenge that it took to do it and the discoveries that we made. Every one of these rocks has told us a chapter in the story of Gale Crater and of Mars for that matter. And so this is just something we're really proud of. And then the next one is another thing it's fun to look at. Two self-portraits that were taken about 10 years apart. One on the left with a squeaky clean rover, and one on the right with a rover that has a lot of dust and sand on it, slowly turning the color of Mars. And I'll also just point out on the right-hand side of the right graphic, you can see some big holes in the wheels, which just, you know, reminds me of all the technical challenges that we've had to overcome in 12 years too. You know, we figured out how to keep the damage of the wheels from getting much worse. We lost a pretty major motor on our drill, the drill that drills all those holes and gets all our samples for us. But our engineers were able to completely redesign the way we drill on Mars to get around not having that motor anymore. You know, and then we lost most of our memory on one of the two computers on the spacecraft, which was another pretty scary event. But again, you know, our engineers came through. They rewrote Curiosity's software to, even though that second computer is no longer capable of running the rover for science, it actually is now programmed to still be able to be an emergency backup should we ever need it if something temporarily goes wrong with our other computer. So, you know, the highest compliment I really can pay to our engineers is that as a scientist, they've just let us keep doing our thing. We don't really notice that anything's wrong because they've addressed all of these challenges and let us keep doing great science.
It's great to see the rover still out there, and that's a great comparison shot with the two selfies. What does the future look like for Curiosity and this incredible team?
You know, I'll show you exactly what it looks like. Here's a picture worth 1,000 words. So we have some amazing levels of Mount Sharp ahead of us. We've been staring at this cliffy unit that you can see up on the left, those tan rocks. unlike anything the rover's been to. We hope to reach those in a few years. We're going to climb more in this river channel that we're in. We've got a lot of great targets. In fact, our team has just been debating where we actually want to send the rover over the next few years. We think it's got several years of great life ahead of it still, and we can't wait to see what we find.
The views in these images are just beautiful that the rover has taken. Thanks for sharing them with us. Before we jump into more of your audience questions, viewers, Sarah, how can our viewers find out where Curiosity is on Mars?
Thanks, Nikki. So, of course, this is still an active mission. And as Ashwin said, there is still so much more to do. There's more climbing to do and more surprises that Gale Crater is going to throw our way. So if you look on the lower portion of your screen, you can see a link, go.nasa.gov, where is Curiosity? That is a location map that is updated every time that the rover drives. So it is completely up to date anytime that Curiosity is climbing or driving around. And it shows you the entire journey, the 12-year journey. So Curiosity's gone almost 20 miles. It just has a little squinch more to go. So Ashwin, can you take care of that for us so we can get to a nice even 20?
We'll do it.
So, and then keep going, of course. So that's a lot of fun. And I check that location map all the time.
Awesome. Thank you for sharing that, Sarah. Let's jump into some more audience Q&A.
All right. I've been digging around here. All righty. So these two interested me. I'm kind of clumping two questions together. So this is Frank on LinkedIn and John on YouTube. Both of them were asking kind of a similar question in terms of, sort of the evidence that you see some sort of liquid flowing on Mars. Frank wanted to know, what makes you think it was water? And then John was saying, how do we know it was water as opposed to some other liquid flowing?
Yeah, it's a good question. We don't specifically know that for, with any certainty. It's really just kind of process of elimination. What's the most likely material that it could have been? Some people have proposed other more exotic, liquids flowing down on Mars, but we think water is probably the most likely in the past. We know that there's a ton of water, of course, frozen at Mars poles. We believe there was a lot more water in the atmosphere when it was warmer. A lot of that water that's now frozen at the poles or lost to space would have been in the atmosphere and could have caused snowfall or rainfall. There's water in the inside of Mars that could have come up in springs, and helped to form some of these lakes. So it's really just the most likely fluid that probably formed all this.
Excellent. Okay, so Bruce McNitch on YouTube. I just lost where I was. It's not Bruce. It's Lightning Rod. Lightning Rod on YouTube. This is a really interesting question. So the water that made all these channels, is it somewhere still on Mars?
Yeah, so there is a good amount of water that's been lost to space. There's also water that has been incorporated into the minerals of Mars, but the one place it isn't anymore is in lakes or oceans, and that's largely because Mars has gotten too cold and the atmosphere has gotten too thin. And so any water that's left on Mars is frozen, and any liquid would have been lost by boiling away at this point. The atmosphere is just too thin to support liquid water today at Mars surface.
Okay, here is a question from YouTube, Iris Kitty. So with sort of the dating of that riverbed, you were giving it in these, sort of millions of years and billions of years. With the dating, how does that compare to what Earth was like when that river was flowing on Mars? What was Earth like?
Yeah, generally Mars, like if you go back maybe 3.5 billion years, there's a chance that Mars could have been the friendlier place to life than Earth at that exact moment in time, which is kind of interesting to think about. Earth may have still been full of a lot of volcanism, that sort of thing, where maybe Mars was in its phase where it had lakes and oceans over a lot of the surface. We're talking 3.5, 4 billion years ago. So we don't know for sure that that's the case, but it is interesting to think about that early in the history of the solar system, Mars might have been the more Earth-like place at that point in time.
Well, I'm happy to stay on Earth right now because I think Mars has maybe changed a bit, could be a wee bit chilly. So Bruce McNitch, sorry, I called on Bruce before. So he's wondering about the current state of the atmosphere on Mars. So could the winds on Mars now make those waves and ripples, or were they formed because the atmosphere was thicker?
Yeah, those particular ripples, we think, of course, formed underwater. Just when we study the detailed shape of them and spacing of the wavelengths and things, they best match waves that form in a lake environment. But there are a lot of ripples on Mars in the ancient past that are now preserved in rock, and also ripples that Curiosity's seen today that form under Mars' current atmosphere. So the atmosphere is only about 1% as thick as Earth's atmosphere is today, but even then, we still see a lot of sand blowing around, and that sand can form ripples and it can form sand dunes, which is pretty remarkable for such a thin atmosphere. And one day, the sand ripples, some of the sand ripples and dunes that we're seeing today moving around might get turned into rock for people to find in rock layers, a million years from now.
Okay, I'm going to mix it up a little bit, going back to sulfur, because people are still intrigued with the sulfur, maybe because it looks like a beautiful yellow crystal. So Cecilia Costilla on YouTube is asking, so could we determine if the sulfur crystals were part of the original formation of Mars, or could have they been brought to Mars from debris or from a meteorite or a comet?
Yeah, that could be hard to figure out. We have considered the possibility that the sulfur came from somewhere else on Mars. Maybe a meteor hit Mars somewhere else where there is a volcano and there was pure sulfur deposits being deposited, and then that debris kind of splashed over to Gale Crater. It just seemed like kind of a stretch to think that we would find this little patch of sulfur rocks right in the middle of this channel that came from somewhere else. But we have to keep our minds open. So a lot of this is going to be, since there's so few clues, a lot of this really for us is going to be what is the most likely explanation. I'm not sure we'll ever be able to really prove how it formed unless we get lucky again, have another happy accident and find more of this and can start finding more and more clues to where it came from.
Okay, and I'm going to go a totally different direction because this is a fun question that we haven't had yet, and it's something that I bet a lot of people wonder about. So MG Rahul on YouTube is asking, looking at the map of Curiosity, it shows the different names of hills and rocks the rover is passing. So how do you come up with those names?
Yeah, there's a couple different ways. So some of the big names, like Gale Crater and Gediz Vallis, are names that are decided by a group called the International Astronomical Union, which names a lot of features across the solar system. And Gale was an astronomer from Australia, I believe. And so people can work with the IAU to get features on different planets named after people that made contributions to astronomy, or sometimes things are named on planets after other things like Shakespearean characters, and other things like that. So it kind of varies. There's different rules for different planets. For a lot of the smaller features that Curiosity encounters, we don't, formalize them through this committee because we have hundreds and hundreds of names that we have to use to keep track of all the things we study. So then the team decides those. And we choose our names based on dividing up the map of Gale into kind of squares, and every square we've themed after an important geological area on Earth. So currently we're driving through an area where we've chosen to theme that part of the map after the mountain range in California called the Sierra Nevada. So it's nice, close to home, and actually it's kind of fun because a lot of our team members have hiked in the Sierra, and we're naming all the rocks and ridges after our favorite lakes and peaks in the Sierra these days.
Thank you. Yeah, that is, it is interesting because sometimes the names are all different and very unusual. And I do remember when we heard from the mayor of Yellowknife Bay in Canada.
Right.
It's a little tiny town in Canada, called up NASA, and I forget what. I think they were going to put a monument in their town square or something.
Oh, excellent.
So I got a question from Simon Farmer on YouTube. So this is interesting. If you were to look at Mars like a mining geologist, what would be the interesting metals to you?
Yeah, we do see. So, one thing I didn't mention about that dark marker band with the wavy ripples in it, that was highly enriched in iron and manganese and zinc. And so just like, on Earth where fluids moving through rocks can move metals around and concentrate them in certain areas, like how you find gold concentrated in certain fractures in rocks, the marker band seems to have concentrated those metals, and that may be one of the reasons why it's so resistant to erosion, so hard. So yeah, we find some copper. We find some interesting things that people have mined on Earth. We haven't found any gold yet, however.
I have been asked that before.
Yeah.
So I'm glad you can confirm that no gold yet. Okay, so there's some interesting questions. People are familiar with this term called ISRU, which is in situ resource utilization on Mars, and that would be important if people were to travel to Mars. So Nicole on X is asking, when humans travel to Mars, and this is in the future, how will these findings make life easier for people colonizing the red planet?
Yeah, it's not something that I'm a real expert in, but we have found places on Mars and in Gale Crater where the minerals have quite a bit of water in them. So I know, when we were studying the clay unit that was a few years ago in the mission, there's a lot of water trapped in those clay minerals. And so you can imagine that if we needed to, we could figure out how to extract that water out of the minerals in the ground. We actually, have, even in the sulfate rocks that I mentioned formed in a drier part of Mars climate, even they have some water incorporated into their mineral structure. And so, there's water that we would need. And of course, just like on Earth, you might look for different kinds of rocks for different things you need to build structures, to make kind of a cement or to extract metal from. So we're finding a lot of useful elements that would help both for survival for astronauts and colonists, as well as for building structures. Okay,
and one question that is kind of related in terms of people being on Mars, or the way, how much we know about the surface of Mars or underneath the surface of Mars. So Rick on YouTube is asking, have there been any measurements taken of the ground temperatures below the surface?
It's a good question. I know we've done some of that on the moon using radio emissions that come from a little deeper down. I'm not 100% sure that's been done for Mars, but we have taken lots of temperature readings of the surface, and we can kind of estimate how the temperature increases with depth, just using the kind of same physics that would occur on a planet like Earth, where we have measured, and that heat's coming from the interior of Mars, and heat's being lost at the surface, and you can kind of measure the surface temperature and extrapolate your way down.
Aha. Okay. And finally, I'm going to take one more question. And that is, it kind of, looks towards the future and what other fun things you're going to be doing with Curiosity. So K Novak on YouTube is asking, are you going to break open more of those white rocks to see what's inside?
Yeah. We broke open more than the one I just showed you. And they all, in that area, they all seem to have those spectacular yellow-green crystals in them. we've had the same kind of happy accident, and even purposeful accident, so to speak, earlier in the mission, where you use every tool that you have when you're exploring Mars with a rover, and one of the things you can do is use the rover's wheels to dig a trench into sand or to break open rocks. And so we've done that on purpose quite a few times, and we've had the accidental discoveries more than once. The sulfur wasn't the first time, but it was the most spectacular one. And just this week, we're parked at a place where we're looking just a few feet ahead of where the rover's parked and seeing some rocks that we crushed with our wheels just a few days ago. And so we're thinking about just kind of moving the rover forward a little bit and checking out those rocks that we just crushed.
That's surprising. I had no idea you've been crushing more and they look the same. That's so exciting.
Who knew they were doing that over there?
So unfortunately, folks, that is all the time we have today for audience Q&A and for our discussion. I want to thank our speaker, Dr. Ashwin Vasavada, for joining us to celebrate Curiosity's 12 years on Mars and this pure sulfur surprise. Also, thank you to our wonderful questions co-host, Sarah Marcotte, and everyone working behind the scenes to make this possible. To all of you watching, thank you for taking the time to join us every month. And next month, we have discussion on exploring ocean worlds. If you missed one or would like to revisit any of our Von Karman series from the past, check out JPL's YouTube page. Thanks again, and we will see you in September. Bye-bye.